We are up to Unit 5-1. You have only 2 vocabulary words. The first one is the rate of change. Rate of change is the change in the dependent variable over the change in the independent variable. Now, the next one you need is slope. We're going to spend a lot of time working on the slope of a function. And what I want you to know is slope is vertical change over horizontal change. A shorthand way to say that is also the rise over the run. Another shorthand way to say that, which I'll be using in your classwork, is, remember the triangle can be a symbol meaning change or delta. Delta y over delta, the change in y over the change in x. Okay. Take a look at problem 1 on page 292. They're asking you to find the rate of change, and they're giving you the information you need in this table over here. Rate of change is change in distance over change in time. In this case, why do we know that? Well, because distance is your dependent variable, time is your independent variable. Okay? How many minutes you've marched determines how far you have marched. And then they show you how you calculate the rate of change if from the second minute to the first minute, 520 feet, 260 feet, your rate of change is 260 over 1. They do the same thing for the next pair, come up with the same rate of change. The same thing with the last pair, same rate of change. So, because of that, we know that the rate of change is constant, and they travel 260 feet every minute. For God at number 1, they want to know what happens if you use non-consecutive rows of the table. For example, what happens if you say 780 minus 260 over 3 minus 1? You know what to do. Go ahead, figure it out. We'll check answers in a second. Well, look at that. If you use non-consecutive rows, as long as you make sure that you're putting in the right numbers, you still get the same rate of change. How convenient. So now at the top of 293, they show you the same information that we've been working with this marching band, but they have plotted it on a graph. And as long as you have a function where the rate of change is constant, then you will have a linear function. What they want you to notice here is that they're figuring out the slope. I had you write down definition of slope before, and of course it didn't make any sense yet. Remember that slope is vertical change over horizontal change, or the rise, which is this way, over the run, which is this way. So to go from this point on the graph to this point on the graph, you have to go, let's see, rise is first, so you have to go up 260 units, and you have to go over from 2 to 3, 1 unit. This one, because the 260 is a little hard to figure out, the next one is going to be simpler. Trust me on it. When you're trying to figure out slope, this is just a little shorthand for you. Take a look. Any line that moves upward as it goes from left to right has a positive slope. Any line that moves downward as it goes from left to right has a negative slope. Any line that is horizontal has 0 slope. That makes sense. You're not walking uphill. It's 0 slope. And any completely vertical line is undefined. We can't do a thing with that. For example, take a look at problem 2. We're trying to figure out rise over run. They've got these 2 points plotted. Well, rise, to go from this point on your graph to the height of that point on your graph, you have to go up 2. That's the numerator of your fraction. How far over do we have to go to get from this point to that point? 1, 2, 3. The run on this line is 3. Rise over run, 2 over 3. This is really quite simple. walk through it one more time. Rise over run on this function, this line. Well, let's start with rise. How far up do we go? 1, 2, 3, 4. And then we're on the same level as that point, right? To get from this point to that point, we've gone up 1, 2, 3, 4. So our rise is 4. For the run, if I start here, I'm moving left, so I'm going to have a negative run. 1, 2, 3, 4, 5, negative 5. You'll notice here the book did this slightly differently than I did, but we ended up with the same answer. You end up with negative 4/5. And come back to this graph that you were looking at earlier, right? Positive slope goes up to the right, negative slope goes down to the left. Just use your brain. If you're looking at a line that goes this way, you know that slope is going to be negative, and if you don't come up with a negative, you've made a mistake somewhere. Now, tackle got it number 2, both A and B. All you're doing is counting the distance across and up for each of these points to figure out the slope. Rise over run. You can do it. I don't think I've said this yet this year, but there's really not any math to show for this. For letter A, you have to go up 2 and over 5. For letter B, you're going up 2 again, but you have to go the other direction 6, so that's a negative slope. So this one's negative 1/3, and like it says, just point and count. So if you are like me, that whole pointing and counting thing makes you a little nervous because you want to be more exact, because you're not sure that you counted right, and maybe you went the wrong way, and it's stressful. You'd rather have a formula. So guess what? Here is your formula. If you have the coordinates of any 2 points on your line, you can figure out the slope. How do you do it? Well, you subtract one y value from the other, you subtract one x value from the other, and that answer is your slope. It does not matter which y value you use first, but make sure you use the same x value first. Okay? That'll make sense in a second. Problem 3. Yay, gridded response. They give you 2 points on this line, -1, 0, and 3, -2. Figure it out. Well, first, write down your formula, and I'm not saying that just to hear myself talk. Write down your formula. Then, they started with -2 minus 0, which is fine, but since they started with this coordinate, when they do the x in the denominator, start with 3 and subtract -1. There's your answer. The slope of that line is -1/2. Try it yourself. They give you 2 points, 1, 3, 4, -1. Write down the formula. See if you can find the slope. All right, you need to have this slope formula written in your notebook, although by next week you'll have it memorized in your brain forever and ever. Slope formula is rise over run, which is equal to y2 minus y1 over x2 minus x1. This says, hey, check out the subscript. These numbers, 2 and 1, are a little bit smaller and a little bit below the y. That's how you write this properly. So when you set up problem 3, you'll notice a couple of things here that I expect you to write down. Here's the formula you're using. Here's the points you're given. I need to see the points. I need to see the formula so that I know that you know what you're doing and so that you can keep track of what problem you're working on. Okay? I figured this out both ways for you. If you start with this point, 1, 3, then you end up with 3 minus -1, and then 1 minus 4, which equals 4 over -3, which is the same as -4/3. If you do it the other way, and you start with this pair of points, then you have -1 minus 3 over 4 minus 1, which, look at that, is the same thing. Problem 4, they're just going over again what we've already talked about on this video. Horizontal line has a slope of 0. A vertical line is undefined. We can't do anything with that. So here's the beauty of problem of got it number 4. Don't write anything down. What's the slope of the line through those given points? Well, look at this in letter A. They're both 4s. So your change in x on the bottom of your fraction, the denominator, 4 minus 4, that's 0. This is a vertical line and it's undefined. What is the slope of that line? Undefined. Now check out letter B. The y values are the same, which means when you go to figure out the change in y on the numerator, you're going to end up with 0, which means this is a vertical line, and that's all you have to figure out. They do go over this one more time on page 295, positive slope, negative slope, undefined, horizontal. Under our new system, you are done with your homework now. You should have everything in your notebook that I wrote in mine. Do not do the lesson check. Do not do these problems. These are for tomorrow in class. And read carefully, because this says you're doing number 8 and number 9. That dash means that you're doing 11 through 13, so you're doing 11, 12, and 13. This is 17 through 19, 26 and 27, number 30, number 33 and 34, and number 42. This, I think, is the right amount of work for one class. We'll see if I'm right or wrong when you get to it. I will have a check sheet for you, so you're going to do these, check them with your check sheet, give me your score at the end of class tomorrow. Good job!